Good evening, everyone. So today we have a class on determinants. Let's wait for a few more minutes. There are some more people who are joining in. So some more people are joining in. So we'll wait for 1 to 2 more minutes and then we'll start the class. So as I mentioned earlier, today the topic is determinants. It's basically the continuation of matrices. It's a part of matrices, but in exams, generally the questions are majorly from determinants. You will see questions on matrices as well, but getting a singular individual question on matrices is not something which the ratio is 3:7. Let's say 30-70%. 30% chances are there that the question will be a matrices question. 70% chances of the question is of being the question that it will be a combination of both matrices as well as determinants. So it will first ask you to let's say calculate a matrix and then apply the determinants concept to get the determinant of the matrix. So let's wait for 1 more minute. I can see that there are people who are joining in now. Good evening, Sukumar. Hi, Rolex. We'll start the class at 8:03 or 8:04. I can see there are some more people who are joining in. Today is a very important topic. Determinants definitely very surety. There is a very sure chance that you will get a question from either from matrices or determinants. So it's a very important topic. It's easy to understand if you have like there are certain formulas if you remember them and if you know the concept which can be applied to get the answer. So it is very easy to solve those questions. Okay, so I think there are a good number of people now. So let's start the class. Okay, so today's topic is determinants. We'll start from the very basic, like what exactly is determinants and where the determinants are used. Generally, you will see the questions of determinants, and majority of the questions are directly formula based. There are some type of concept which you have to apply, or there's some approach which you have to apply to get to that form, the answer which you need. But ultimately, it's just a formula based question. So let's start this. So first of all, I am hoping that there are a good number of people who have already given these 5 free mock tests for IIMB UG, for the IIMB UG exam. These are available free of cost, and these mocks are created by the people, by the alumni of IIM Ahmedabad, Bangalore, and Calcutta. So I'll definitely suggest you to give these mocks. As I mentioned it earlier as well in the previous classes, that this is the first time when IIM Bangalore is conducting a undergraduate examination. So the best paper, the paper which can be expected, can be formed by someone who have been there, or somebody who have already been in those IIMs. So the alumni of IIM A, B and C, they can definitely provide you the gist of what actual paper can be. So I'll definitely suggest you to give these 5 mocks. These are currently what we think is as far as the actual paper. Also, this will give you like where do you stand, like in what topics you are good at, in what topics you are weak at. And since we have good number of days, I think we have roughly around 20 to 25 more days. In these 20 to 25 days, we can improve our weak topics as well. This will help. This will definitely help you to get a good score in the exam. So just try these mocks. You can directly Google search IIMB UG mock test Cracku. You have to click the very first link which will be coming, and you will be redirected to this page, and do give these 5 free mocks. It will be very beneficial for you. Apart from it, I'll request you to subscribe to our YouTube channel. The reason being, we are conducting these live sessions from very long, I think from roughly around October last week till we are running these classes up till 13th of December. That we have a schedule up till 13th of December, which is the IIMB actual examination. So you can see yesterday we had a classes on matrices. Before that we had DI basics, probability, and then before that was quadrilaterals. All these topics are very important and have a very high weightage to come in the IIMB UG exam. Apart from it, we have next 2 very important classes, something which is very difficult to understand. So I'll definitely suggest you to attend these 2 classes, which is on calculus 1 and calculus 2, where we will discuss all the calculus related topics like limits or derivatives or integral calculus, differential calculus, everything. So I'll definitely suggest you to attend these 2 classes, as well as then we have logical reasoning, and up till 13th of December we are covering all the major important topics which can be asked in IIMB UG exam, or which has a very high chances of being asked in the examination. So subscribe to our channel, as well as I'll request you to hit the like button. We are doing all of this, we are providing all this content for free, and this like gives us the motivation to continue this hard work. Your 1 like is kind of a booster for us to make things available for you at best. So I'll definitely suggest you to hit this like button. Apart from it, we also have a WhatsApp channel. So the link is in the description box. I'll definitely suggest you to join this WhatsApp channel if you have not joined the WhatsApp channel. First of all, it is helpful for you to be preparing for the examination with the like-minded people. So in those WhatsApp channel, I think there are many students in the channel who are preparing for IIMB UG exam. So let's say this is the first time they are conducting the exam. So you might be, you can be lost. You don't know what to do or how to prepare for, or what exactly to prepare for. So join the channel, and we are updating about everything, every update which we are getting from IIMB UG. We are posting that update on our WhatsApp channel as well as our YouTube channel. So you will be updated. I think in the next few days, they will release their official mock as well. So join this WhatsApp channel, as well as subscribe to the YouTube channel as well, to be updated about whatever action is being taken by IIMB UG for their examination. So apart from it, so let's start our today's class. As I said, today's class was on determinants. Determinants is a very important, and it's a continuation of matrices. So what exactly is a determinant of a matrix? So determinant is a scalar value which is associated with a square matrix. So there is you can see a 2 cross 2 matrix and a 3 cross 3 matrix. So 2 cross 2 matrix and 3 cross 3 matrix, there is a scalar value which is associated with these matrices. That scalar value, what exactly is that, is we are going to discuss in the next slides. But this scalar value is something which is unique to every matrix, every square matrix. So the determinant is that unique scalar value which is associated with the square matrix. So it represents a matrix scaling factor, volume change, whether the matrix is invertible or not. This is very important, whether the matrix is invertible or not. We will discuss in the further classes about inverse of a matrix. But if, let's say, determinant of a matrix is 0, then it is non-invertible, and if it is non-zero, it is invertible. We will discuss about this in the next, maybe in the next classes, about when we will be discussing about the inverse of the matrix. But this is a very important criterion for the matrices. Then it is denoted by det of, that is determinant of A or mod of A. It is not exactly called as mod. It is, this symbol is basically called as determinant of A, determinant of matrix A. Then again another very important condition, that it is defined only for the square matrices, that is matrices of the order n cross n. What were square matrices? As we discussed yesterday, these are matrices which have equal number of rows and columns. So equal number of rows and columns is are the one which are square matrices, and these determinants are only defined for the square matrices, not on any other matrices. Let's say if the matrix is of the order 2 cross 3, so this is not a square matrix, so determinant is not possible for this. Also, if determinant is 0, if determinant of any matrix is 0, it is called as singular matrix. It is called as singular matrix, or the matrix is called as singular. Otherwise, it is a non-singular matrix. So this is also very important condition, that if determinant of a matrix is 0, it is singular, and if determinant of matrix is non-zero, then it is non-singular. So what will happen? Sometimes they'll just give you a 3 cross 3 matrix, let's say, with some elements in that matrix. Let's say there is some x equation, there is some x variable for which you have to solve, and they'll tell that this matrix is singular. So there is some variable x for which you have to solve, and they'll tell that this matrix is singular. So reading that singular matrix, you should directly relate that it is, the determinant of the matrix is 0. So this is about singular matrix. They can directly give you that matrix is either singular or non-singular. So reading that, you should be able to just put that determinant of A is 0 or it is not 0. So this was about a basics of determinants. So let's move to the next slide. Sumino, I think we haven't got the official number yet about this thing, but whenever we get any official number, we'll update you on the YouTube channel as well as the WhatsApp channel. So whenever we'll get the number, we'll definitely update you. There will be good number of people, since IIM Bangalore is a very good college. It's a very reputed college and roughly holds a legacy of 60 plus years, I think. So you can expect a good number of people giving this examination. So now one very important thing, while calculating the determinant of the matrix, two things you should understand very clearly, which is minor of a matrix and cofactor of a matrix. So these two are very important concepts of matrices. So it is minor and cofactor. Let's discuss about minor first, that what is the minor. So the minor of an element in a matrix A is the determinant of the submatrix obtained by deleting the ith row and jth column. So I'll explain you what it is saying. It is denoted by Mij. So let's say this is a determinant. Sorry, this is a matrix. What exactly is the minor of a matrix is? So minor is basically for each element there will be a minor. So for this A11, A is equals to Aij, right? A is equals to Aij is the general matrix form. Now this is A11, this is A12, this is A13. Then this is A21, A22, A23, A31, A32 and A33. So what exactly is it is saying that first of all minor is possible for all the elements. For A11 the minor will be M11. For A12 the minor will be M12. For A13 the minor will be M13. So for each corresponding element there will be a minor. Now let's say how to calculate minor, that is M11. First we'll take the minor of first row and first column element. So what it is saying is that you have to delete the ith row and jth column. So what exactly does it mean? It is saying that you have to delete the ith row and jth column, which means you have to remove this row and remove this column. So remove this row and remove this column. You have to just remove these elements. Let's say this, there is nothing. This is the only thing which is left. That is, you're only left with 0, 1, 2 and 3. So this is basically a 2 cross 2 matrix. How to calculate the determinant of 2 cross 2 matrix is basically you have to cross multiply and subtract. So what we have to do is 0 into 1 minus 3 into 2. This is the determinant of a 2 cross 2 matrix. Okay, let me just move to the next slide first before completing this. So first it is important that what exactly is the determinant of a 2 cross 2 matrix. So A is equals to, let's say 2 cross 2 matrix is A is equals to A, B, C and D. So how exactly is determinant of 2 cross 2 matrix is calculated? It is by this formula. So what you have to do, you have to multiply diagonal elements, the diagonal elements, the this diagonal and this diagonal, and you have to subtract the both the elements. So what you have to do is first you have to multiply A by D. So this is A, B, C and D. You have to multiply these two values first. So this will become determinant of A is equals to AD minus, you have to multiply these two values. So AD minus BC. The determinant of A is AD minus BC. So for example, let's say this is your matrix A. So how to calculate the determinant of 2 cross 2 matrix? As I said earlier, you have to first multiply these two elements. So 4 into 3 minus, you have to multiply these two elements, 7 into minus 2. So 4 into 3 minus 7 into minus 2. So what will happen? This 4 into 3 is 12 and this minus 7 into minus 2 is 14. So 12 plus 14, which is equal to 26. So determinant of A is 26. Let's take one more example of a 2 cross 2 matrix. Let's say it is 3, 5, 2 and 4. 3, 5, 2 and 4. How to calculate that? Let's say this is a B matrix. Then determinant of B, how to calculate it? Multiply these two elements first. That is A11 and A22. So it is A11 into A22 minus A21 into A12. So this is the formula. So A11 into A22 is 3 into 4 minus, you have to multiply these two elements now. First this one, that is from 1 1 to 2 2 and then from 1 2 to 2 1. So 3 into 4, which is 12, minus 2 into 5, which is 10. So 12 minus 10 is equals to 2. Let's take one more example of a matrix with negative values. So this is minus 1, minus 7, minus 2 and minus 3. Let's say this is a C matrix. Again similar case, determinant of C is, you have to multiply these two values first. So minus 1 into minus 3 minus, minus 1 into minus 3 minus, you have to multiply these two values now, minus, minus 2 into minus 7. Now minus 1 is into minus 3 is what? 3 minus, minus 2 into minus 7 is what? Plus 14. So 3 minus 14, determinant of C is minus 11. So this is how you calculate a matrix of a determinant, the determinant of 2 cross 2 matrix. You have to cross multiply and then subtract the elements. You can just remember this formula. If a matrix is A, B, C and D, A, B, C and D, then determinant is AD, move this thing, determinant is AD, product of A and D minus product of B and C. A and D minus product of B and C. So if you have any doubt regarding how to calculate the determinant of 2 cross 2 matrix, you can ask. So yeah, good number of people have already given the mocks. Roughly around 1500 plus students have given the IIMB UG mock. This is the actual, not exactly to say will be very accurate, but it is 80%. We are very sure that these are the topics which will be definitely be there in the IIMB UG examination. So again, I'll tell you to give these exams, take the mocks and see where exactly do you stand, and recognize the, as said earlier, that we have good number of days. 25 days are enough to work on your weak topics. So like just figure out what topics you are weak at and then work on it. 25 days is a good number of days. So give these mocks and get the understanding of where do you stand. So I think we have no doubts in this one. So now let's move to minors and cofactors. So understanding of a determinant of 2 cross 2 matrix. I think this slide should be before before calculating the minors and cofactors. So that's why I took determinant of 2 cross 2 matrix. Now let me explain you what exactly is how to calculate the minors and cofactors of the matrix. So as I mentioned earlier, how to calculate the minor of a 3 cross 3 matrix. So what you have to do, you have to delete the ith row and jth column. Let's say you are finding the minor Mij. So what you have to do, you have to delete the ith row and jth column. So what I was doing, I was finding M11, that is first row and first column I have to delete. I deleted the first row as well as first column, and this is what we are left with, 0, 2, 3, 1. This is what? This is a 2 cross 2 matrix. This is a 2 cross 2 matrix. And what does minor definition say? The minor of an element in matrix A is the determinant of the submatrix obtained by deleting the ith row and jth column. So this is what? This is the submatrix. This is the submatrix which we got after removing first row and first column. So determinant of this matrix, this submatrix will be what? As I said earlier, what you have to do? You have to multiply these two elements first. So 0 into 1 is 0, minus 3 into 2 is 6. So 0 minus 6 is equals to minus 6. So M11 is what? Minus 6. So what I'll do, I'll create this minor matrix now. So M11 is what? Minus 6. Also, there is a corresponding element for each element of the matrix, original matrix. So the order of both the matrix, that is the original matrix as well as the minor of that matrix, will be same. If it is 3 cross 3, this will also be 3 cross 3. If it is 4 cross 4, then the other will be also 4 cross 4. So this is about M11. Now let's calculate M12. Let's calculate M12. So M12 is what? Again, you have to follow the same thing. Delete the ith row and the jth column. Delete the ith row, I is what? 1 here, and j is 2. Delete the ith row, okay, deleted. Delete the first row, deleted. Delete the second column, jth column, okay, deleted. So these two are deleted, it is not there. So what is the submatrix which we are left with? The submatrix which we are left with is 3, 2, 2 and 1. So 3, 2, 2 and 1. So this is the submatrix which we are left with. Now this is 3 into 1, which is 3, minus 2 into 2 is 4. The determinant of this submatrix will be 3 into 1, which is 3, minus 2 into 2, which is 4. So 3 minus 4 is equals to minus 1. So what is M12? M12 is minus 1. What is M12? After removing ith row and jth column, we got this submatrix, and determinant of this submatrix is minus 1. So this become our minor 1 2, minor for the first row and the second column. So this minus 1 I'll put here. Now we have what? We have M13. Again similar procedure, remove the ith row and jth column. Ith row and jth column. So for M13 what we have to do? J will be 3 now. Remove the first row, that is first row is removed, and remove the third column. So third column is also removed. So we are left with what? This is 3, 0, 2 and 3. So this is the submatrix which we are left with. What exactly we have to do now? We have to cross multiply these elements. So 3 into 3 is 9 minus 2 into 0 is 0. So 3 into 3 is 9 minus 2 into 0 is 0. So 9 minus 0 is 9. So M13 is what? 9. Now what you have to do? I have to find out this value which is M21. What does M21 says? M21 says remove the second row and the first column. So remove the second row, which is I have removed the second row. I am finding M21. So second row and remove the first column. So now what sum matrix is we are left with is 2, 0, 3 and 1. We are left with the sub matrix 2, 0, 3, 1. What we will do? We will calculate the determinant of this matrix. So this will be what? 2 into 1. So 2 into 1 is 2 minus 3 into 0. So 3 into 0 is 0. So 2 minus 0 is 2. So my M21 is 2. That is second row and first column minor is 2. So this will be 2. Now what we have to do? We have to find out M22. We have to find out M22. So M22 is what? You have to remove the second row and the second column. We have to remove second row and second column. So what is there? So this is 1 into 1, which is again we are left with a submatrix of 1, 0, 2 and 1. 1, 0, 2 and 1. Whatever the elements we are left with is basically a submatrix. So we are left with 1, 0, 2 and 1. So 1 into 1 is 1 minus 2 into 0 is 0. So 1 into 1 is 1 minus 2 into 2 is 0. So 1 minus 0 is equals to 1. So this one is our M22. So this is our M22. Now what we have to find out? We have to find out M23. Same procedure, remove the second row and the third column. Remove the second row, third column. What we are left with is submatrix of the elements 1, 2, 2 and 3. So now again find the determinant of this remaining matrix, which is 1 into 3 is 3 minus 2 into 2, which is 4. So 3 minus 4 is minus 1. So my M23 is minus 1. Now M31. Again remove the third row and the first column. So third row and first column. 2 into 2, again 2 into 2 is 4 minus 0 is 0. So 4 minus 0 is 4. So M31 is 4. Then we have M32. Minor of third row and second column. Again remove the third row, M32 and second column. So what we are left with? 1 into 2 minus 3 into 0. 1 into 2 minus 3 into 0. So this is 2 minus 0, which is 2. So this element will be also 2. Now we have M33. Again same formula use, same approach we have to apply for every minor. What we have to do? We have to remove the third row and the third column. We have to remove the third row and the third column. So we have to calculate, this is our remaining sub matrix, and we have to calculate the determinant of this matrix. So this is 1 into 0, which is 0, minus 3 into 2, which is 6. So 0 minus 6 is minus 6. So this will be minus 6. So now this matrix which we have received after applying the operation on matrix A is basically a minor matrix. This is our minor matrix. Now what is cofactor matrix? The cofactor of an element in a matrix A is Cij is minus 1 की power I plus j upon Mij. So what will happen where Mij are the minus of the matrix? So what will happen? Cij, as per the formula it says minus 1 to the power I plus j into Mij. Cij minus 1 to the power I plus j Mij. Again let's say if I have to find out C11, what will happen? Minus 1 what will happen? Minus 1 1 plus 1 M11 minus 1 1 plus 1 M11 minus 1 to the power 1 plus 1 M11. So this will be minus 1 1 plus 1 is 2 minus 1 ka square is 1. So C11 will be M11. What about C12? C12 will be minus 1 की power 1 plus 2 into M12. So C12 will be 1 plus 2 is 3 minus 1 to the power 3 is minus 1. So this will be minus M12. This will be minus M12. Now what we have? we have C13. So what will happen with C13? This is minus 1 to the power 1 plus 3 M13. So C13 is 1 plus 3 is 4 minus 1 to the power 4. So every even power will give us a positive element, positive 1. So this will be minus 1 to the power 4 is 1. So C13 will be M13 only. So what exactly will happen in a 3 cross 3 matrix is basically, let's say this is your minor matrix. This is your minor matrix with some elements. Let's say these are A, B, C, D, E, F, G, H, I. Let's say some elements are there. So what will happen if I have to find out the cofactor matrix, that is if I have to find out Cij, I have to find out Cij, what exactly changes I have to do on this minor matrix is basically I have to change the symbols of these elements. I have to change the symbol from plus to minus for 1, 2. So this will be plus, this C11 will be equal to M11. The C11 is equals to M11 as mentioned, so this will remain positive. C12 is equals to minus of M12, so this sign will change. The sign will be negative here. Then C13 is equals to M13 because the power is even, so again the sign will remain positive only. Now for C14 the power is what? 1 plus 4, which is 5. Odd power will give me negative. So this will be minus. Then we have what? Sorry, this is C21, 2 plus 1 is 3. 3 is again an odd power, so this will give me a negative element. Now what will happen with C22? 2 plus 2 is 4. 4 is even. So even power of minus 1 will give me plus 1. So this will be plus. Then here it is what? C23. So 2 plus 3 is what? 5. 5 is an odd number. So what will happen? This will be minus. So this will remain negative. The sign will change here for minor matrix. Now again for this one, this is C31. 3 plus 1 is 4, which is even. So this will be plus. Then C32. 3 plus 2 is 5, which is an odd number. So this will be minus. The sign will change here for these elements. For this one, this one, this one and this one, the sign will change. That is, it will become from plus to minus. Now this is C33. 3 plus 3 is 6. 6 is again even number. So this will remain positive 1. So what will be the Cij matrix for this one? What will be the cofactor matrix for this one? As I mentioned it earlier, I have to change the symbol of this element. This element, this element and this element. For a 3 cross 3 matrix. Remember, for 4 cross 4 matrix you have to do you have to calculate for which values the symbol will be changed and for which values the symbol will remain same. So for this M12, M21, M23 and M32 the symbol will change. So what we will do, this minus 1 will become plus 1. This 2 will become minus 2. This minus 1 will become plus 1 and this 2 will become minus 2. As I mentioned, the signs of these elements will be changed. So signs of this element, this element, this element and this element will be changed from positive to negative or negative to positive. There will be a change in sign. So minus 1 is changed to 1, 2 is changed to minus 2, minus 1 is changed to 1 and 2 is changed to minus 2. Now rest for all the elements the symbol will remain same. So this will be minus 6, this will be 9, this will be 1, this will be 4 and this will be minus 6. So this is your cofactor matrix. This was a minor matrix. Remove the ith row, remove the jth column, we will get a submatrix and the determinant of that submatrix will be your minor element. Now for cofactor matrix you have to change the sign for particular elements in the matrix for which the power of their sum of indexes is odd. So for odd power the sign will be changed from minus, it will become plus or the plus will become minus. Rest for all the elements it will remain same. So this is your cofactor matrix. So let me write once again. My A is 1, 2, 0, 3, 0, 2 and 2, 3, 1. So A is 1, 2, 0, 3, 0, 2 and 2, 3, 1. 3, 0, 2 and 2, 3, 1. And my cofactor matrix is minus 6, 1, 9, minus 2, 1, 1 and 4, minus 2 and minus 6. Now what exactly is determinant? Determinant is multiplying basically the any row, like any row corresponding element with the any row corresponding element of the original matrix multiplied by any row corresponding element of the cofactor matrix and then adding these elements. So let's say if I have to find the value of determinant of A, let's say I am taking this first row. So I have to take the first row of the cofactor matrix as well. Now I have to multiply the corresponding elements. I have to multiply first row first element with the first row first element of the cofactor matrix. Then first row second element of original matrix to first row second element of the cofactor matrix, and first row third element of the original matrix with the first row third element of the cofactor matrix, and then I have to add these products. So what exactly I am saying is basically I have to multiply this 1 by minus 6. So 1 into minus 6. Then we have to say 2 into 1 plus 2 into 1 plus 0 into 9. So 0 into 9. So 1 into minus 6 is what? Minus 6 plus 2 into 1 is what? 2 plus 0 into 9 is 0. So the determinant of matrix will be minus 4. Determinant of matrix is minus 4. Now you can take any row or any column, this determinant will remain same. Let's say instead of taking the first row, I am taking the third row. So what will happen with third row? 2 into 4 is 8. 3 into minus 2 is minus 6. And 1 into minus 6 is minus 6. So again 8 minus 6 is 2. 2 minus 6 is minus 4. So this value is also minus 4. So you can see these two values are same. Let's take some column now. Let's say I am taking this column. I am taking the second column. So I have to take the second column of the cofactor matrix as well. So I am taking the second column of the cofactor matrix. Now this 2 I will multiply by 1. So 2 into 1 plus 0 into 1. So plus 0 into 1 plus 3 into minus 2 plus 3 into minus 2. So this will be what? 2 into 1 is 2. 0 into 1 is 0. So 2 plus 0 is 2. And 3 into minus 2 is minus 6. So 2 minus 6 is minus 4. So this is minus 4. So you can clearly see, you can take any row, multiply by the corresponding row elements of, multiply the corresponding elements and then add them. You will get the determinant value is same. The determinant of this matrix is what? Minus 4. And the general procedure is what? You have to first calculate the minor matrix. And then you have to calculate the cofactor matrix. By first minor matrix is removing the ith row, jth column, and cofactor matrices you have to change the symbols for the elements for whom the sum of indexes is an odd number. Then after getting the cofactor matrix, you can take any row of the original matrix and any row of the any row of the original matrix and multiply the corresponding elements with the corresponding row of the cofactor matrix. Add them and you will get the determinant. Take any row, any column, you will get the value as same, which is minus 4. In this case is minus 4. So do you have any doubt in this one? First of all, good evening all rounder. Thank you so much, Arvant. This really gives us the motivation to basically provides us a boost to provide you more and more content so that you can perform well in this examination. If you have any doubt regarding this one, like how to calculate the minors, cofactors, or ultimately how to calculate the determinant, you can ask. After this, I'll tell you how to what is the short approach to calculate the determinant. So I think there are no doubts. So let me tell you the trick for calculating the determinants. Now, how to calculate the determinant fastly? So first of all, what exactly is the matrix? Matrix is 1, 2, 0, 3, 0, 2 and 2, 3, 1. So my matrix is 1, 2, 0, 3, 0, 2 and 2, 3, 1. This is 1. Now how to calculate the determinant fastly? You don't like calculating first the minors and then calculating the cofactors and then multiplying the corresponding rows of the original matrix as well as cofactor matrix and then adding the elements can be a little tedious. It will require a lot of time for you to get the determinant. But the fast approach is what? What you have to do here is basically you have to first of all consider any row. Any row you have to consider. In general cases, we will take the first row. So what I'll do, I'll take the first row. Now what I'll do, determinant of A, I'll take this element as 1. So I'll take this 1 and what I'll do, I'll remove this row and column. So I'll left with this thing 0, 2, 3 and 1. I'll calculate the determinant of this submatrix which I've got. So this submatrix of 0, 2, 3, 1, I'll calculate the determinant. What is the determinant? This is 0 into 1 minus 3 into 2. So this is 0 into 1 which is 0, minus 3 into 2 is minus 6. So this will be 1 into minus 6. Now this will be, first of all, this will be a plus. Now since you remember, if I take the second element, this element is what? A12. This element is A12. So when we were calculating the cofactor, what we were doing, we were changing the sign of this minor. So what minor which we were getting for A12, we were changing the sign. So because why? Because I plus j, that is 1 plus 2, is an odd number. So we have the minus 1 power, the odd power of minus 1 will be minus 1 only. So this minor will become negative. That is, the symbol will be changed for the minor. Similarly, instead of taking this as plus, what we'll do, we'll take this as minus. So we'll take this as minus. We'll take this as minus. Now what I have to do, I'll take the second element of the row which I have taken. So this is 2 into, now what I'll do, I'll remove this row, the row containing the basically the ith row and jth column I have to remove. So I am choosing the A12 element, so I have to remove the first row and second column. So first row and second column is removed. Now we are left with 3, 2, 2 and 1. So 3, 2, 2 and 1 is what? 3 into 1 minus 2 into 2. So 3 into 1 minus 2 into 2. This will be what? Minus 2 into 3 1s are 3 minus 4. So 3 minus 4 is minus 1. Now for A13, 1 plus 3 is again positive. So we don't have to change the sign. The sign will remain negative. So what is this? This is 1, 3. So what we have to do, I have to remove the first row and the third column now. I have to remove the first row and third column. So what I'll do, I'll take this element is 0 first of all. So 0. Now I'm left with this matrix 3, 0, 2 and 3. So what I have to do, I have to calculate the determinant of this submatrix. So this is 3 into 3 which is 9 minus 2 into 0. So this is 3 into 3 minus 2 into 0. So this will become 0 into 3 3 is 9 minus 2 into 0 is 9 minus 0 which is 9. Now 1 into minus 6 is what? Minus 6. Minus 2 into minus 1 is plus 2 and plus 0 into 9 is 0. So this will be minus 4. This was the determinant which we got by calculating the cofactors as by multiplying the row of the original matrix with the corresponding row of the cofactor matrix, and the same value is we are getting by using this trick. Same value we are getting by using this trick. Again, same thing, you can do it with other rows as well. So let's say this is 1 2 0, 1 2 0, then we have 3 0 2, then we have 2 3 1, 3 0 2 and 2 3 1. Yeah. So what I can do, I'll take now the second column. Let's say I have to calculate the second column. So what I have to do, I'll first take 2. Now this is A12. So first row and second column, I have to remove this one. I have to remove the first row. I am left with what? 3, 2, 2 and 1. Also this is A12. So 1 plus 2 is 3. 3 is an odd number. So what will happen? Determinant of A will be minus 2 into 3 1s are 3 minus 2 into 2. So 3 minus 4. 3 into 1 is 3. 2 into 2 is 4. So 3 minus 4 is minus 1 plus. Now this is 0 and this is A22. This is 0 and this is A22. 2 plus 2 is 4. Even number, sign will not change. So this will remain plus only. So 0 into, now second row will be removed and first row will be there. Now I have to find out, I am taking A22. So second row and second column is removed. So this is 1 into 1 which is 1 minus 2 into 0 is 0. So 1 into 1 minus 2 into 0 is 0. So 1 minus 0 is 1. Now this is, we will take A23. So now what we will do is we have deleted the second column as well as third row. So this is also 2 and 3. A23 is 2 plus 3 is 5. Again odd power. So I have to change the sign. So this will become minus 3. This is 1 into 2. We are left with 1, 3, 0 and 2. So 1 into 2 is 2 minus 3 into 0 is 0. So 2 minus 0. So minus 2, 3 minus 4 is minus 1. So 2. So minus 2 into minus 1 is 2. Plus 0 into anything is 0. and this is minus. So minus 3 into 2 is minus 6. So 2 minus 6 is again minus 4. So determinant of A is minus 4. You can take any row, any column. You can apply the same formula and get the answer, get the determinant. This is the trick which we are using. It is generally advisable to use this first row as the the base condition. Like you should always take the first row and then calculate the determinant of the submatrix. So this from this where we get to the our general formula of determinant of a 3 cross 3 matrix, which is this one. Let's say if our 3 cross 3 matrix is A, B, C, D, E, F, G, H, I. So what I have to do? I have to take the element A, remove the first row, first column, A into EI minus FH. A into EI minus FH. So A into EI minus FH. Now I have to take first row and second column. So I'll take this element. As I mentioned earlier, the sign will change because 1 plus 2 is 3, 3 is odd. So the sign is changed. First of all, minus B we have taken, and now what we'll do, we'll remove first row and second column. So this is DI minus GF. So DI minus FG. Now for the first row and third column, so what we'll do, first row, third column, 1 plus 3 is 4. So that will remain positive only. We'll take C and plus C. So plus C into, now this 2 will be removed. First row and third column is removed. We are left with D, E, G and H. So this will be DH minus GE. So DH minus GE. So this is the determinant of A. I have already calculated the determinant of A in the previous slide. I will calculate it once again. So determinant of A will be what? This is 1 into, we are left, we will remove this one and this one. This is 0 into 1 minus 3 into 2. So 1 into 0 minus 6. Now for this 2, the sign will change. So this will be minus 2 into 3 into 1 minus 2 into 2. So 3 into 1 minus 2 into 2 is 3 minus 4. Now for this third element 0, the third element, it will remain positive. So plus 0 into 3 into 3 is 9 minus 2 into 0 is 0. So 9 minus 0. So again this will be minus 6 plus 2 plus 0, and this will again be minus 4. So determinant of A will be minus 4. If you have any doubt in calculating the determinant of matrix, you can ask. Okay, Sharvant, we will try to provide the PDF of this session also. Maybe today is not possible, but from tomorrow onwards, we will definitely try to provide the PDF of this session. So I think there are no doubts. If you have any doubts, you can just ask. We'll discuss the properties of determinants and then we'll solve the questions there. Okay, so let's move to the next slide now. So let's move to the next slide. Now we have properties of determinants. Now these properties are generally used in many cases. So I'll tell you which all properties are important. So the first property is very important. Swapping two rows or two columns will change the sign of the determinant. That is, if B is obtained by swapping two rows of A, then determinant of B is minus A. Let me take the previous example only. This is 1, 2, 0, 3, 0, 2 and 2, 3, 1. So my matrix was 1, 2, 0. It was 1, 2, 0, 3, 0, 2 and 2, 3, 1. 302 and 231. What it is saying, if we swap two rows or two columns, the determinant will change. So what I'll do, I'll swap these two rows. So this is my A, B will be what? I have to swap these two rows. So this will become, this 302 will become my first row and this 120 will become my second row. So my second row is first row and my first row is second row, and third rows remain same. So 120 and 302. Now let me calculate the determinant of this matrix, determinant of B. Determinant of A was what? Minus 4 as calculated in the previous slide. Now let us calculate the determinant of B. Again take 3, This is 2 into 1, which is 2, minus 3 into 0 is 0. So 2 into 1 minus 2 minus 0 is 2. Minus 0 into 1 into 1 is 1, minus 2 into 0 is 0. So 1 minus 0, which is again 1, plus 2 into 1 into 3 is 3, minus 2 into 2 is 4. So 3 minus 4. So this is 3 to the 6, minus 0 into 1 is 0, plus 2 into minus 1 is minus 2. So 6 minus 2 is what? 4. So you can clearly see that the determinant of B is 4 and determinant of A is minus 4. So when we have swapped two rows, that is when we have made first row the second row and the second row the first row in B, where we made the changes, the determinant is changed. Determinant of B is equals to minus of determinant of A. Same goes with the column as well. If you swap these two columns, I won't calculate the matrix. You can try it at home. When you will swap the two columns, again the determinant will be changed. So again, very important property. Swapping two rows or two columns will change the sign of the determinant. Then we can say if two rows or two columns are identical or proportional in matrix, then determinant of A is 0. Let's say I have a matrix which is 1, 2 and this is 2 and 4. So it is not equal, the first column is not equal to the second column, but if you check the ratio of the elements in the first column and the second column, this ratio is what? 1:2. And this ratio is what? 1:2. So the proportion of column A is 1 and proportion of column 2, column 1 is 1 and proportion of column 2 is 2. So if the proportion is same for all the row, the determinant will be 0. So this is a 2 cross 2 matrix. What you can see, how to calculate the determinant? Determinant is 1 into 4, which is 4, minus 2 into 2, which is 4. So 4 minus 4 will be 0. So determinant will be 0 if the two rows or columns are identical or proportional. Here we can see the proportion is 1:2 in the rows as well as the columns. If any row or column of a matrix is all zeros, if the entire row is zeros or the entire column is 0, then it will be the determinant will again be 0. You can consider this one, that if this row is 0, 0 and 0, if this row is 0, 0, 0, so this value will be 0, this value will be 0 and this value will be 0. So 0 multiplied by anything will be 0 and adding up 3 zeros will ultimately be 0 only. So if any of the row or column is 0, all the elements of that row or column is 0, it will be a 0 matrix. For a triangular matrix, the determinant of matrix is the product of all the diagonal elements of the matrix. Again, what was a triangular matrix? Triangular matrix was upper triangular, all the elements below the diagonal is 0, and lower triangular, all the elements above the diagonal are 0. So there is only one element which is left with non-zero element, which is A11. If I talk about, let's say, upper triangular matrix, A21 and A31 are 0. So if I consider the column, what will happen is basically I have this A11 which is some value, A21 and A31 is 0. Again, let me just explain here. If I am talking about upper triangular matrix, so 1, 2, 3, upper triangular is 0, 0, 0, or let me take a lower triangular matrix. So lower triangular matrix is the elements above the diagonal will be 0. So this is 0, 0 and 0, and this is, let's say, 2, 4 and 1. Now what will be the determinant? Now these two are 0. So 0 multiplied by anything will be 0 only. So what we have to take? We have to just take 1. So this will be 1 into 2 into 3 is what? 6. Minus 1 into 0 is what? 0. So 1 into 6 minus 0 is equal to 1. So the determinant of this lower triangular matrix is 6. Now what is the product of these three elements, which is the diagonal element? The product of the diagonal elements is again 1 into 2 into 3, which is 6. So the product of diagonal elements is 6. So this is what it is written, that for a triangular matrix, the determinant of matrix is the product of all the diagonal elements of the matrix. Yeah, Prachi will be solving the questions after this slide. We have questions. Then transpose of a matrix. If we take the transpose of a matrix, which is swapping the rows and columns, the row become the column and column become the rows. So determinant for the transpose matrix will remain same as discussed in the previous class. Determinant of two matrices product. So if I have a matrix, let's say C is equals to AB. So determinant of C will be determinant of AB. This determinant of AB can be written as determinant of A into determinant of B. So determinant of C will be determinant of A into determinant of B. Similarly, determinant of product of A, B, C will be the individual product of the determinants. So determinant of A multiplied by determinant of B multiplied by determinant of C. Again a very important property. Then this is very important. I'll tell you the difference first of all. K times determinant A will be K times determinant A only. K times determinant A will be K times determinant A only. But determinant of K times A, determinant of K times A will be K to the power multiplied by determinant A, where n is the order of the matrix. This is different. This, in the first case, you are multiplying the determinant by some scalar constant. So there the value won't be changed. But when you are multiplying the matrix with a scalar constant, you are making it Ka and then calculating the determinant of that matrix. So the determinant of matrix will be K to the power n into A. Determinant of A. Let's say determinant of A is 3. So 3 times determinant of A will be what? 9. But determinant of 3A will be, if A I say, let's say is 2 cross 2 matrix. A is 2 cross 2 matrix, so n is equals to 2. So determinant of 3A, when the matrix A is multiplied by 3, all the elements are multiplied by 3. So this will be 3 square into determinant of A. 3 square into determinant of A is 3. So 3 square into 9 into 3, which is 27. So this is a difference between multiplying the determinant by a scalar quantity and multiplying the matrix by a scalar quantity and then calculating the determinant. So this is mentioned here. If you multiply a matrix by a scalar quantity, the determinant of that matrix will be K times n into multiplied by determinant of A, where n is the order of the matrix. And determinant of any identity matrix is equal to 1. It is always true that determinant of any identity matrix is always 1. If you have any doubts in this slide, you can ask, or shall we move to the questions now? So let's move to the questions. Majorly these properties you have to remember. These properties will be used in the coming questions. So, and you have to apply some concepts of matrices, let's say matrix addition, matrix multiplication, or some other concept, and then you will get the answer. So let's go with the first question now. Okay, we have three more properties, again very important. So if A is invertible, we'll discuss this further, like what is a inverse of a matrix. But if A is invertible, what does A is invertible means? That determinant of A is not equal to 0. That is, A is a non-singular matrix, determinant of A is not equal to 0. Then determinant of inverse of a matrix A is 1 upon determinant of A. We'll discuss this in detail later when we will be discussing about determinant. When we'll be discussing about the inverse of the matrix. Multiplying a row or column by a scalar K multiplies the determinant by K. Again same thing, if you multiply a row by K, let's say this is in the previous case, if I multiply this by 3, this first row by 3, so this is now 3, 6 and 0. Again what will happen, this entire thing will be multiplied by 3. If I multiply this by 3, let's say this will be 9, 0 and 6. So this will become what? This will become 9, this will be 0 only, and this will be 6. So the entire this equation is multiplied by 3. So what will happen? This will also be multiplied by 3 and this will also be multiplied by 3. If I multiply first row by 3, all the elements, all the corresponding steps, I have to multiply the entire row by 3. So determinant of B will be 4 into 3, which is 12. So since I multiplied by a scalar constant 3, one of the row, the determinant is also multiplied by the scalar constant. So this is also again very important. Then if vertices of a triangle are x1, y1, x2, y2 and x3, y3, the area of the triangle is given by half of x1, y1, 1, x2, y2, 1 and x3, y3, 1. There should be a determinant mod as well. You have to always take the positive value. So half into mod of determinant of x1. So you have to calculate the determinant. Now if this value is negative, you have to take the mod. So this will be positive. Again if it is positive, mod of positive is positive only. And then you have to multiply these values by 1 by 2. Multiply by 1 by 2 and you will get the area of the triangle with vertices x1, y1, x2, y2 and x3, y3. So let's move on to the questions now. If you have any doubt, you can ask in the chat. So this is the first question. So time is up. Let's solve this question. Again, this question, you can expect the questions of matrices and determinant with some, it will be merged with some other topic as well. So that you can clearly see that it is merged with some quadratic equation concepts as well. But it's very easy to solve. So let's check this one. Whatever is given in the question, just solve it step by step and you will get the answer. So it is given that if matrix A is alpha minus 2, 7 and beta. So this is a 2 cross 2 matrix where alpha and beta are the roots of the equation x square plus 6x plus p. So x square plus 6x plus p equal to 0 is a quadratic equation and its roots are alpha and beta. The roots are alpha and beta. And determinant of a plus 2i is equals to 8. I told you yesterday as well, you cannot ask what exactly is I. I is a identity matrix. It is implicit in the question that I represents a identity matrix and it is of the same order with the matrix with which it is added. So if A is a 2 cross 2 matrix, this I is also a 2 cross 2 identity matrix. So this I is what? I is equals to 1, 0, 0 and 1. Then what is the value of P? We have to find the value of P. Step by step, just keep solving the question. What is given to us? First information given to us is that alpha and beta are the roots of this equation. Alpha and beta are the roots of this equation. Second information is determinant of a plus 2i is equals to 8. Now I know a and I know I as well. So what exactly I have to do? I have to find the determinant and I am given the determinant of a plus 2i which is equals to 8. So a plus 2i is equals to 8. Now let me first find the value of what exactly is this a plus 2i. So a plus 2i is, so if I write a plus 2i, this is basically, what is matrix A? Matrix A is alpha minus 2, alpha minus 2. Well done Surya, you are correct. Joshua as well. Bhavna, you are also correct. Surya is also correct. So let me just solve this. This is alpha, this is minus 2, this is 7 and this is beta. So this is our matrix A plus twice of identity matrix. So plus 2 times identity matrix will be what? I have to scalar multiply the matrix by 2. So this will become each element I have to multiply by 2. So this will become 2, 0, 0 and 2. So this is a plus 2i. So what exactly is a plus 2i? A plus 2i, I have to add the corresponding elements, the similar process which we use for matrix addition. So this will be what? This will be alpha plus 2, then minus 2 plus 0 is minus 2, 7 plus 0 is 7 and this is beta plus 2. So a plus 2i is this matrix. A plus 2i is this matrix. Let's say I am assuming it as C. So if I tell you to find the determinant of C, if C is this matrix, what will be the determinant of C? Again 2 cross 2 matrix, you have to multiply this diagonal first and subtract this diagonal. So what exactly you have to do? You have to multiply alpha plus 2 into beta plus 2 minus 7 into minus 2. Minus 7 into minus 2. If we open this equation, this will be like, if we further simplify this equation, it will be alpha beta plus 2 alpha plus 2 beta plus 4 and minus 7 into minus 2 is plus 14. So plus 40. This determinant, we are given the determinant of a plus 2i, that is determinant of C. A plus 2i is C. So determinant of C is equal to 8. So this value is equal to 8. So I can write alpha beta plus twice of alpha plus beta plus 4 plus 14 is 18 is equals to 8. Now we solve the first, we use the first condition, we use this information, that is determinant of a plus 2i is 8. Now we have to use further information. Further information is given that this equation's roots are alpha and beta. We have alpha beta which we have to solve and we are given that we have equation x square plus 6x plus p equal to 0 whose roots are alpha and beta. What can we say? We know that sum of the roots of the equation are minus b upon a. So alpha plus beta is what? Minus b upon a is minus 6. Then product of the roots of the equation is c by a. So alpha into beta is equals to what? C is p and a is 1. So p by a, p by 1 which is p. So alpha plus beta is minus 6 and alpha into beta is p. We will substitute these values in this equation. So alpha beta is p plus 2 into alpha plus beta is what? minus 6. So 2 into minus 6 plus 18 is equals to 8. So P plus this will be minus 12. So 18 minus 12 is plus 6. So P plus 6 is equals to 8 and we will get P is equals to 2. In the question it was asking for the value of P only. Therefore the value of P is equals to 2. This means the answer of this question is 2. If you have any doubt in this question, you can ask now. So let's move to the next question if there are no doubts. So I'll pose the next question now. Try this one. Okay. So I think this is the IIMB previous year question. This is the IIMB previous year question. Give this a try. So the time is up. Let's solve this question now. Again, you will see a lot of questions in matrices and determinants with quadratic equation concepts being merged with these questions. So let's solve this one now. Let Px be a quadratic polynomial. Whenever you read this, first of all just write what exactly is Px. Px is a quadratic polynomial. Directly write it. Px is equals to ax square plus bx plus c. So this is a quadratic polynomial. Such that determinant of this, that is P0, P1, P0 and P2 is equal to 0. So determinant is given as 0. Let P0 equal to 2. So it is giving the value of P of 0 equal to 2 and P1, P2 plus P3 is equal to 14. First of all, P of 0 is equal to 2. This means that I have to substitute the value of x equal to, when I substitute the value of x equal to 0, P of x will be what? 2. So if I substitute the value a 0 square plus b into 0 plus c, this should be equal to 2. Now this is 0, this is 0, so 0 plus c is equal to 2, so this implies c is equals to 2. C is equals to 2. So our equation is now ax square plus bx plus 2. We have calculated the value of c. Now it is further given that p of 1 plus p of 2 plus p of 3 is equals to 14. Again, if I put the value of x as 1, 2 and 3 and I add all of them, I'll get the corresponding value as 14. So if I put the value of 1 in this equation, it will be a plus b plus c. So a plus b plus c plus, if I put the value of x equal to 2, this will be 4a plus 2b plus c. So 4a plus 2b plus c. If I put the value of x equal to 3, this will be 9a plus 3b plus c, and this is equal to 14. If I put the value of x as 1, 2, 3, you will get these three equations. Now what will happen? A plus 4a plus 9a is 14a. A plus 4, 1 plus 4 is 5, 5 plus 9 is 14. B plus 2b plus 3b is 6b, so 14a plus 6b, and c plus c plus c. So there are 3c, and we have already calculated the value of c. So 3 into c, which is 3 into 2, which will be 6. So 14a plus 6b plus 6 is equals to 14. This implies we will get our first equation as 14a plus 6b is equals to 8. We have this equation now. We are given one more thing. We are given the determinant of this matrix is 0. So what this is, what a 2 cross 2 matrix. This is a 2 cross 2 matrix. So what you have to do, you have to multiply these two elements and then subtract these two elements, the product of these two elements. So it will be P0 into P2 minus P0 into P1, and this is equal to 0. So it is given P0 into P2 minus P0 into P1 is equal to 0. I'll take this on the right hand side. So this will be P0 into P2 is equals to P0 into P1. Now this P0 and P0 will be cancelled because it is not equal to 0, it is equal to 2, so it can directly be cancelled. So it is given that P2 will be equal to P1. So if I put the value of x equal to 1 and if I put the value of x equal to 2 in this equation, the values will be same. As per this equation, as per the determinant case, P2 will be equal to P1. So what is P2? P2 is 4a plus 2b plus c. So P2 is 4a plus 2b plus c. And what is P1? P1 is a plus b plus c. So this will be equal to a plus b plus c. The c and c will be cancelled. And this, if I take b that side and I bring 4a this side, so this will give me b is equals to minus 3a. This will give me b is equals to minus 3a. So 2b minus b will be b, and a minus 4a, it will be minus 3a. So b is equals to minus 3a. This b equal to minus 3a, I will put in this equation. This 14a plus 6b equal to 8. So what will happen? 14a plus 6 into what is b? B is minus 3a is equals to 8. So 14a plus 6 into minus 3 is minus 18. So 14a minus 18a is minus 4a. So minus 4a is equals to 8. That implies a is equals to minus 2. I'll put the value of a in this equation now. B is equals to minus 3a. So what will be b? B is equals to minus 3 into minus 2. So b is equal to 6. So now I have the value of a, I have the value of b, as well as I have the value of c. So I'll just write them down. A is equals to minus 2, b is 6, and c is 2. So my quadratic equation will be what? Px is equals to ax square plus bx plus c. So px is equals to minus 2x square plus 6x plus 2. Minus 2x square plus 6x plus 2. Now let's see what is being asked in the question. The question is asking then P4 equals, it is asking for the value of P of 4. So what I have to do, it is asking for P of 4, that is I have to put the value of x equal to 4. I have to replace the value of x equal to 4 to get the value of P4. So minus 2 into 4 square plus 6 into 4 plus 2. 4 square is 16 and minus 2 into 16 is minus 32. Plus 6 4 is 24, so 24 plus 2. So minus 32 plus 24 is minus 8, and minus 8 plus 2 is minus 6. So P of 4 is equal to minus 6, and therefore option C is the correct answer, that is value of P of 4 is minus 6. No Prachi, I think you missed something. It is not minus 10, it is minus 6. If you have any doubt in this question, you can ask. Good, Joshua. Shall we move to the next question now? If you have any doubt, you can ask. I'm moving to the next question now. I'll clear the doubt in the meantime. So give this question a try. Again, as discussed earlier, we discussed about the property of determinant of Ka. So this is k to the power n into determinant of a. Apply this concept to get the answer. So time is up. Let's solve this question now. So this question, it basically merges the concept of it merges the concept of matrices and determinants as well as some number system concept or some exponents concept. So it is given, let A, B, C be 3 cross 3 matrices such that determinant of A is 6, determinant of B is 2 and determinant of C is 5. So determinant of A is 6, determinant of B is 2 and determinant of C is 5. Okay. If the value of determinant of 12 times, so this 12 is multiplied by the matrix, it is multiplied by the matrix. So it is a scalar multiplication of matrix and then we are calculating the determinant of the matrix. So it is the case determinant of Ka is equals to K times n into determinant of A, where n is the order of the matrix, is equals to 2 to the power x, 3 to the power y and 5 to the power z. So what is given? This is given as determinant of 12 a4 b square and c to the power 5 is equals to 2 to the power x into 3 to the power 5 y into 5 to the power z. So 2 to the power x into 3 to the power y into 5 to the power z. Now what is the value of x plus y plus z? So it is asking for the value of x plus y plus z. So first of all, we'll take this 12 out. When we are taking this 12 out, this will be what? This will be 12 to the power n. What is the n here? It is a 3 cross 3 matrix. So n is equals to 3. N is equals to 3. So this will be what? This will be 12 ka cube. This will be 12 ka cube. When this 12 will come out, this will be 12 ka cube. And this is determinant of a4 b square c5 is equals to 2 to the power x into 3 to the power y into 5 to the power z. So this 12 cube, now we can open this up as well. We can simplify this equation as well. So 12 cube, determinant of a to the power 4 into determinant of b to the power 2 into determinant of c to the power 5. We first of all discuss about determinant of a, b, c is equal to determinant of a into determinant of b into determinant of c. Also we discuss that determinant of a to the power n is equal to determinant of a to the whole power n. Determinant of matrix a to the power n is equals to determinant of a to the power n. So these two things I have, these two properties I have applied here. This is equal to 2 to the power x, 3 to the power y and 5 to the power z. 12 cube can be written as 2 square into 3. 2 square into 3, because now we have to simplify everything into powers of 2, 3 and 5. So this is 2 square into 3 का whole cube into what is determinant of A? Determinant of A is 6. So 6 can be written as 2 into 3. 6 can be written as 2 into 3. So this will be 2 into 3 to the whole power 4 into determinant of B square. Determinant of B is 2. Since I have to bring everything in powers of 2, 3 and 5, I won't change it. So this is 2 ki power 2 into determinant of C is 5. So this will be 5 to the power 5. And this is equal to 5 to the power 5. This is equal to 2 ki power x into 3 to the power y into 5 to the power z. This will be what? This is 2 into 3. So this will become 2 to the power 6 into 3 to the power 3. Into this is will become 2 into 3 to the power 4 will be 2 to the power 4 into 3 to the power 4. Into 2 square will be 2 square. And into 5 to the power is 5 to the power 5. This is 2 to the power x into 3 to the power y into 5 to the power z. Now this is 2 and this is 2, the powers will add up. So 6 plus 4 plus 2, which will be 6 plus 4 plus 2 is 12. So this will be 2 to the power 12 into 3 to the power will add up. So 3 and 3 are here. So 3 to the power 3 and into 3 to the power 4 will be 3 to the power 3 plus 4. This is 3 to the power 7 into 5 to the power 5 is equal to 2 to the power x into 3 to the power y into 5 to the power z. We can compare these values, 2 to the power x with 2 to the power 12, 3 to the power y to 3 to the power 7 and 5 to the power z to 5 to the power 5. Value of x will be what? 12. Y will be 7. We are comparing this one and this one, this one and this one, and this one and this one. So x is 12, y is 7, z is 5. So what is the value of x plus y plus z? It is 12 plus 7, 19, 19 plus 5, 24. So x plus y plus z is equals to 24. So our correct answer will be x plus y plus z equal to 24. If you have any doubt in this one, you can ask. Good, Joshua. I think we should move to the next question now. So I'm posting the next question now. Try this one. Okay, this is A equal to 1 0 0 0 0 1 and 0 1 0. Then the absolute value of this is what? Absolute value is basically you have to take the mod. If you get a negative value, you have to convert it into positive and you have to type the answer. That will be your answer. So if your matrix is this, what will be the determinant of this? The absolute value determinant. With this, I'll say apply some matrix multiplication concept and you will get some pattern. Calculate a square. When you will calculate a square, you will get a pattern. You will realize that this a square is something. The time is up. Let's solve this one now. we're given the matrix A is equals to 1 0 0 0 0 1 0 1 0. It is asking for the absolute value of the determinant of A9, A6, A3, A. It is asking for this value A9 plus A6 plus A cube plus A. First of all, whenever you see very high powers of any matrix, let's say this is power of 9, the very first intuition which you should get is basically after A square or A cube or A to the power 4, the matrix will be repeating itself. Let's say A to the power 4 is equal to A. Then again A to the power 5, A to the power 6, A to the power 7 will be again A. Then A to the power 10 will be also A. So there will be a pattern which will be repeating. So if I am given A is equal to this, what I'll do, I'll first calculate what is A square. So A square will be 1 0 0 0 0 1 and 0 1 0 multiplied by, I have to perform matrix multiplication here. So this is 1 0 0 0 0 1 and 0 1 0. Matrix multiplication, it is a 3 cross 3 and this is also a 3 cross 3. These two values are equal. So the matrix A square will be what? This will be a matrix of order 3 cross 3. So this will be equal to 3 cross 3. Now I discussed yesterday how to perform the basically the matrix multiplication. If you have to find the element in the final matrix, in the multiplied matrix of ith row and jth column, you have to take the ith row of the first matrix and jth row of the jth column of the second matrix, and you have to multiply the corresponding elements and add them up. So what I am saying is, I'll take for this A11, I'll take first row and first column and I'll multiply the corresponding elements. So this is 1 into 1 is 1, 0 into 0 is 0 and 0 into 0 is 0. So 1 into 1 is 1, 0 0 0 and 0 into 0 is 0. So 1 plus 0 is 1. So my A11 will be 1. Similarly 1 2 will be what? I have to take the first row and second column. So now I'll again multiply. 1 into 0 is 0, 0 into 0 is 0 and 0 into 1 is 0. So this is 0. Again first row third column for A13, I'll take this column. So 1 into 0 is 0, 0 into 1 is 0 and 0 into 0 is 0. So this element will also be 0. Now second row and first column. 0 into 1 is 0, 0 into 0 is 0 and 1 into 0 is 0. So this will be 0. Second row second column. 0 into 0 is 0, 0 into 0 is 0 and 1 into 1 is 1. 0 plus 1 which is 1. So this element will be 1. Now 0 into second row third column. So 0 into 0 is 0, 0 into 1 is again 0 and 1 into 0 is again 0. So this will be 0. Then third row and first column. So this is 0 into 1 is 0, 1 into 0 is 0 and 0 into 0 is 0. So this is 0. Then third row and second column 0 0 0, 1 0 0 and 0 1 0. So this will also be 0. Third row third column 0 into 0 is 0, 1 into 1 is 1 and 0 into 0 is 0. So 0 plus 1 plus 0 is 1. So what is this? The diagonal elements are 1 and the other elements are 0. So this is exactly what? This is a identity matrix of 3 cross 3 order. A square is equals to I. A square is equals to I. So A square is a identity matrix. Now what will happen? If you remember if you remember the properties which we discussed in the yesterday class, any matrix multiplied by the identity matrix is equal, will give you the same matrix. So if I say A square is equal to I, and if I pre-multiply this, let's say I'm pre-multiplying the this equation by A, by matrix A. So A into A square will be A into I. This implies A into A square is what? A cube. And A into I, any matrix multiplied by the identity matrix, the matrix will remain same. So A cube is equals to A. Similarly, if I multiply this this equation, pre-multiply by A. If I pre-multiply this equation by A, so A into A cube will be A into A. That implies this will be A to the power 4. A to the power 4 is equals to A square. And what is A square? A square is I. So A to the power 4 is I. So what will happen? A square, that is all the even powers, will be A square, A4, A6, A8. The pattern will keep on repeating itself. It will be equal to I. And A cube, A to the power 5, A to the power 7, A to the power 9. This will be what? This will be equal to A. The odd powers will remain the matrix as A, the pattern will be repeating, and for even powers it will be equal to I. Now see what we are given. We are asked about determinant of a to the power 9, a to the power 6, a cube and a. The determinant of a to the power 9, a to the power 6, a cube plus a. First of all, what is determinant? What is a to the power 9? A to the power 9 is a. What is a to the power 6? A to the power 6 is I. A to the power 3, a to the power 3 is a. And we have a. So we have to find the value of determinant of 3a. Determinant of 3a plus I. So determinant of 3a plus I. What is a? A we are given as 100, 001 and 010. So a is equals to 100, 001 and 010. 001 and 010. So this is a. I have to find the determinant of 3a plus I. If I say, let's say c is equals to 3a plus I. C is equals to 3a plus I. So what I have to do? I have to matrix. I have to do the scalar multiplication of matrix A by 3. So this will be what? This will be 3 0 0 0 0 3. Just a moment, guys. 300 003 and this will be 030. This is what? This is 3a plus I. I is basically what? Identity matrix of 3 cross 3 order. So this will be 1 0 0 0 1 0 and 0 0 1. Again I have to do the matrix addition here. So this is equal to 3 plus 1 is 4, then we have 0 and then 0 again. Then we have 0 again, then 0 plus 1 is 1, so this is 1 and 3 plus 0 is again 3, so this is 3. Then we have 0 plus 0 is 0, 3 plus 0 is 3 and 0 plus 1 is 1. So this is our matrix 3a plus I. Our 3a plus I matrix is this one. This is 400, 013 and 031. Now we have to find the determinant of 3a plus I. Determinant of 3a plus I. So how you find the determinant is basically you first will take this element, you will remove this row and this column and cross multiply. So this will be 4 into 1 into 1 is 1 minus 3 into 3 is 9. So 4 into 1 minus 9 plus this is 0. Now we have to take the negative. As discussed in the second slide, then how do you calculate the determinant of 3 cross 3 matrix? This is minus 0 into you have to remove the first row and second column. So 0 into 1 is 0 minus 0. So again 0 into 0 will be 0. So this will be 0 plus again this is 0. 0 into 3 is 0 and 0 into 1 is 0. So 0 into 0 again this will be 0. This will be 4 into minus 8. 4 into minus 8. So determinant of 3a plus I is equals to minus 32. Determinant of 3a plus I is equals to minus 32. And what is this 3a plus I? 3a plus I is this only. So this determinant of a to the power 9 plus a6 plus a cube plus a is determinant of 3a plus I. So what I can say, that is determinant of a to the power 9 plus a to the power 6 plus a cube plus a is equals to minus 32 only. It is asking that we have got the determinant of this expression as minus 32. In the question it is asking for the absolute value. So what is the absolute value? Absolute value is minus 32. We have to take the positive. We have to take the mod of this thing. We have to convert the negative to positive, and if it is positive we have to consider the positive only. So negative to positive minus 32, absolute value will be what? 32. So this will be equal to 32. Thus the determinant of absolute value of determinant of a to the power 9 plus a to the power 6 plus a to the power 3 plus a will be equal to 32. So this is our answer. If you have any doubt in this question, you can ask. If you have any question, you can ask. So I think that was it. In the next session of matrices and determinants, we'll discuss about the inverse of the matrix, as well as certain other questions we'll take on determinants and inverse and adjoint of the matrix as well. We'll definitely discuss about these things in the upcoming classes. Today was the class which was completely focused on determinants. I hope that you understood this thing. What I'll suggest you now is basically go and give these mocks. Whatever is your preparation, how much you have done, how much you are done with the syllabus, don't worry much about it. Just give these 5 mocks. Give these 5 mocks, and in the future we might provide you 5 more mocks. We might provide you with more number of mocks. So what I'll tell you is basically subscribe to the YouTube channel, as well as keep visiting the IIM B UG Cracku website. There we'll update everything about whatever we are updating. If you are coming up with 5 more mocks, so subscribe to the channel. We'll update on the YouTube as well if you are coming up with 5 more mocks, or let's say any number of mocks we are providing, or after we get the sample, after we get the official mock from IIM Bangalore, we'll try to replicate that mock, the same level of questions in our mock test. So do give these mocks. We'll keep the mocks for free for this entire IIM B UG. We are trying to give, we are giving everything for free, every content, every mock, every video is for free. So I'll suggest you to give these 5 free mocks, and further we'll provide 5 more mocks. So before providing those mocks, I'll definitely want you to try these mocks. See where do you lack, see what exactly are your weaknesses. We have 25 more days as mentioned earlier, which are more than enough to work on your weaknesses. So give these mocks, it will be very helpful. As I mentioned it earlier at the start of the class, these are created by the alumni of IIM Ahmedabad, IIM Bangalore and IIM Calcutta. So you will be, you will get an actual gist of the paper, like what exactly can be asked in the actual examination. Apart from it, subscribe to the YouTube channel. We have the next classes on calculus, logical reasoning, and all other topics which have very high probability to come in the IIM B UG examination. We are discussing of that. So when you will be going to the examination, we are very sure that 80 to 85% of your syllabus will be completed. We'll definitely complete topics which will cover roughly around 80 to 85% of the syllabus. Definitely there will be something 10 to 15% which IIM Bangalore might provide, and if you find it in the official mock, we'll include those other topics as well. But up till now, let's say the next 2 classes are for calculus. Do attend these classes. These are topics which are very difficult to understand, but if you understand this concept, you practice good number of questions on these topics, you will definitely do good in the calculus topics. And apart from it, join the WhatsApp channel as well. As I mentioned earlier, any updates we are providing on YouTube as well as WhatsApp. But what WhatsApp is providing you more is basically some like-minded people who, like you, are preparing for the IIM B UG examination. So interact with them if you are finding any difficulty with the examination, or you can just post your doubt, or you can just mail us, or you can do you can directly you can just put the comment in the comment section, and we'll definitely clear all your doubts. So with this, I would like to end the session today. Thank you so much for attending the classes, for attending this class. Tomorrow is calculus. Do attend the class as well. Tomorrow and day after tomorrow. It is from 3 to 4 p.m. The tomorrow's classes is an evening class. So it is from 3 to 4:30 p.m. So do tune in. These are very important topics: calculus, matrices, determinant. From now on, all the important topics are being discussed. So do tune in for the classes. Thank you so much for attending the class. If you have any doubts or any queries, you can directly mail us, or you can put in the comment section of this video, or you can put it in the WhatsApp channel as well. We'll definitely reach out to you. We'll definitely handle your queries. But thank you so much for attending today's live. Do like the video and do subscribe to our channel. Thank you so much.